Alright guys, welcome back. So in this particular video, we are going to start our lessons on vectors and scalars. Okay, and we are going to start from scratch to finish. Alright, now this class is in different sections. So this is the first part of the class, and what we are going to be doing is, first of all, we'll just look at the theoretical aspect of vectors and scalars, and then we'll look at the addition of vectors for vectors in the same direction, vectors in opposite direction. Okay, so in the next class, we'll look at vectors acting perpendicular to each other. In part 3, we'll look at vectors at other angles to each other. And then in part 4, which will be the final part, we'll look at resolution of vectors. Okay, so let's begin. So we'll start by the definition of vectors. What are vectors and what are scalars? So vectors and scalars are, two terms in physics that are easy to define, okay? And most students are familiar with the definition, all right? That's why I didn't even bother putting it right here on the board. Okay, so vectors are quantities that have both magnitude and direction, while scalars, on the other hand, they are quantities that have only magnitude but no direction, okay? Say, for instance, you can have something like this. I can say that the man is moving, or the car is moving with a speed of 100 meters per second, okay, meter per second. So this is speed. Alright, but if I now tell you that the man is moving 100 meters per second towards the right, so at this point I have given you the direction that, oh, it is not just moving with this particular speed, it has a direction towards the right. So at this point it is now velocity. Okay, so you can see that speed is among the scalar quantities here and velocity is among the vectors. So when a speed does not have direction, you call it speed. The moment it has direction, you call it velocity. Okay, so vectors, they have magnitude. Okay, that means they have numerical values. It could be 5, it could be 10, it could be 50. Like this particular one I use now, the magnitude is 100 meters per second. Okay, now if I now add direction towards the right or towards the left or towards east, towards north, towards south, at that point in time, I am now dealing with a vector, and that can no longer be speed because speed is a scalar, so it becomes velocity. So scalars, they only have a value and a unit. Okay, meter per second is the unit here. Okay, but they don't always have direction. Meanwhile, vectors, they will have both magnitude, that means this numerical value, and this unit you can see here, and at the same time they also have a particular direction where they are heading to. Okay, so that's the difference between vectors and scalars. So for exam condition, vectors are quantities with both magnitude and direction, and scalars are quantities with only magnitude but no direction. All right, now you can see the examples, common examples of vectors and scalars. There are others, okay, there are others, but these are just some common ones and you should take note of them. So examples of vectors, you can see them clearly listed. All right, velocity, acceleration, displacement, force, momentum, field intensity, moment, torque, impulse, magnetic flux. Okay, please take note of this field intensity. Very important. Field intensity can be magnetic field intensity, gravitational field intensity, electric field intensity, whatever field intensity, provided it is a field intensity, it is vector. All right, and you should take note of that. Now, for the scalars, you can see the common examples. There are others. So all the 7 fundamental quantities we have in physics, they are all scalar quantities. Okay, so if you are asked to list scalar quantities, you can start by listing the 7 fundamental quantities, and by the time you are done with that, you will have gone a long way. Okay, so all these you can see here: speed, mass, distance, time, length, temperature, pressure, power, energy, work done. They are all scalar quantities. Now you should take note of these two guys: energy, work done. Okay, when we say energy, we mean any kind of energy, whether potential energy, kinetic energy, solar energy, heat energy, whatever energy, provided it is an energy, okay, it is a scalar. And work done too, if you are good in physics, you will know that work done and energy, they have the same SI unit, that's joules, okay? Joules is the SI unit, so any quantity measured in joules is scalar, all right? Now, apart from that, what else do you need to take note of? All potentials too, sorry I forgot to include that, all potentials, okay? All potentials, they are all scalars. For instance, you can have magnetic field potential, electric field potential, and gravitational field potential. Okay, all potential are scalars. Meanwhile, all intensities are vectors. Intensities vectors, potentials scalars. All right, note that, and very important, very important. Okay, in case you need a mnemonics, you can use a mnemonic to learn them. All right, maybe you can even try VIPs. Okay, VIPs can be helpful, meaning that intensity is a vector, potential is a scalar. Okay, so with this you can use it to differentiate them, because students often confuse between potential and intensity. Which one is vector, which one is scalar? So you can actually use a simple mnemonics to just put that on your head. Okay, so these are very important, because most of the time your examiner will not always ask you what's vector, what's scalar. but instead we want to test you if you know examples of vectors and scalars. Okay, so let's move on to look at addition of vectors. We'll look at vectors going in the same direction, and look at vectors going in opposite direction, and that will be all for this particular video. So in the next one, we'll look at vectors acting perpendicular to each other. Then the next one, we'll look at vectors at any other angle to each other, and then we'll look at resolution of vector in the final part of the video. So with that, we'll be done with the whole of vector in physics. So let's quickly go over to the next part of this class. Okay, now let's look at the addition of vectors, and we're going to be handling the first case, which is vector acting in the same direction. Okay, when we say vectors are acting in the same direction, what do we mean? Let's take force as an example. Okay, we always use force as an example when we are illustrating vectors. All right, the quantity we always use when talking about vectors are usually force and velocity. Okay, sometimes we use displacement too, but it's mainly force and then velocity and then displacement, but they are all vectors. So let's use force as an example. Let's take, for instance, there is a mass here. Okay, let's say there's a box here, and then I apply a force, let's call it F1, pushing the box in this direction, and then let's say my friend apply another force here, let's say F2, also pushing in this direction. Now you can see that both my force and the force of my friend, we are both pulling this particular object towards this direction. So these two forces, they are both acting in the same direction. Okay, so this is the condition we want to look at in this particular video. All right, so now take note that vector acting in the same direction, they are also called parallel vectors. All right, when we say parallel vector, it means they are acting side by side. They are not inclined to each other at any angle. As in this case, you can see that this one is going this way, this one is going this way, so they are both, side by side. All right, this is called parallel vector. Okay, so vector acting in the same direction, take note, they are also called parallel vectors. And also you can choose to also call them vectors acting at an angle of 0 degrees. Okay, 0 degrees. So anything parallel is always at an angle of 0 degree. Okay, it is just a constant. Anytime you see anything that are parallel to each other, whenever you see two lines, a line like this and a line like this, since they are side by side, okay, they are parallel, it means that the angle between them, is 0 degrees. Please take note of that. Okay, so you can either call this vector acting in the same direction, or you call them parallel vectors, or you call them vectors acting at 0 degrees to each other. That means the angle between the two of them is 0 degrees. Okay, now whenever you are faced with vectors acting in the same direction, how do you sum them up to get the resultant? When I say resultant, what do I mean? I just put the definition here and you can clearly see it. Okay, so resultant, when we're talking about resultant vector, we're talking about that single vector. Take note, it has to be a single vector, only one. Resultant vector cannot be two, it has to be one. Okay, it's a single vector that has the same magnitude and direction as two or more vectors put together. All right, now take for instance, let me use as an illustration. Okay, now I can say, for instance, I have 5 oranges, and then my brother has 5 oranges, and my mother has 5 oranges, and my father has 5 oranges. We all have 5 oranges each, and we are in the same house. Okay, now if somebody now asks me, how many oranges are in your house? I can choose to say I have 5, my brother has 5, my mother has 5, my dad has 5. Then the person will know how many oranges in the house. Or I can just choose to say, oh, there are 20 oranges in the house. That's putting all the 5s together. 5 plus 5 plus 5 plus 5. That's a total of 20. So at that point in time, that 20 I just mentioned is like the resultant. Okay, that 20 covers all the oranges that belongs to everybody in that house. Okay, now in this case, now you can see F1. Let's take for instance that this F1 that I'm applying is, let's say, 20 Newton. Okay, and then this one is, let's say, 20 Newton. We are both applying 20 Newton on this box. So if I now ask you, Dele, what is the force pulling this box this direction? What are you going to tell me? You will not just tell me 20 here, 20 here. No, you will use your common sense to add up the two to give you only one. You will not say, oh, it is 40 Newton that is pushing the box in that direction. That's you adding up these two forces together. So whenever you add two forces or two vectors acting in the same point, if you add them up together, your answer is called the resultant. Okay, the resultant. So you can see that I can either say, oh, 40 Newton is acting on this box, or I can say 220 Newton forces are acting on this box. I'll be correct. So while this is a component vector, this particular 40 Newton, which is the total of them all, is called the resultant vector. So resultant vector is what you get when you add up all the component vectors together. Okay, that's why I said the resultant vector is that single vector that has the same magnitude and direction as two or more vectors put together. So let's take for instance that there's another vector here, another vector still acting. Let's say this one is 50 Newton. Okay, so if I now ask you what's the total force acting, you will sum up 20 and 20 and 50. You sum them up together and tell me that there's a total of 90 Newton force acting on the body. So this 90 Newton becomes the resultant. Okay, this resultant is representing all of them put together. All right, and of course this 90 Newton is the magnitude. The direction is still this way because all of them are pushing it this way. So this box will move this way. Okay, so that's just the concept of resultant vectors. So now let's take a look at this particular illustration. Let's say this is a level ground. Okay, let's assume there's a ball here. Okay, not really the ball, the football you play, but let's just say there's a round object. Okay, let's call it a round object. There's a round object here, and then Colade is pushing with a force of 50 Newton, and Kolakpo is pushing with a force of 20 Newton, and then Kayode is pushing with a force of 80 Newton. Okay, now Colade, Kolakpo, and Kayode, they are all pushing this particular object in the same direction. Okay, so these are vectors moving in the same direction, and they are moving towards the right. Okay, and in this part I would love to introduce the cardinal points. We're going to be working with the cardinal points rather, okay, because most of the time in physics you always work with the cardinal points. All right, north, east, west, and south. So as a physics student you should know the cardinal points. Very, very crucial. If you don't know it, you can't really handle vectors, to be frank. Okay, you can't. So upward is north, downwards is south, towards the right is east, and towards the left is west. Okay, so these are the four cardinal points. You should be able to tell, the four cardinal points. So from these cardinal points now, if I now ask you which direction are all these forces pushing this ball to, like this way now is which direction? Is it north, east, west, or south? Of course, you guessed correctly. It is east. Okay, you guessed correctly if you actually said east anyways. So this direction is east because you can see the direction of east is towards the right. Okay, so if they are pushing towards the left, then it is now west. If they are pushing it up, that's forward, it is north, downward is south. Okay, so very, very important, and it should also be noted. Okay, now let's say that these three of them, sorry, they are pushing this ball towards east. So at this point in time, if I now meet you and ask you what is the resultant vector acting on this body, what's the resultant vector acting on this body, what are you going to tell me? Of course, you will just sum them up together to get the magnitude, and then you tell me the direction. Okay, because when you're working with vector, you must tell us the magnitude and direction. That's what makes a vector a vector. If you just tell us the magnitude only without telling us the direction, my brother, my sister, what you have given to us is a scalar, not a vector. Okay, so if I'm going to get the result, now what am I going to do? I'm going to add them together. Okay, because they are going in the same direction. Please take me whenever you want to add vectors going in the same direction, you just plus everything. Okay, it's just to add them together. That's how you handle vector acting in the same direction. All right, so since they are going in the same direction, it means that the resultant is equal to 50 plus 20 plus 80. Okay, so if you do this correctly, then the resultant vector is equal to 150 Newton. All right, now 150 Newton is the magnitude. You have to tell us the direction. Where is the direction? Is it going east? Is it going north? Is it going west? Is it going south? Of course, your eyes are very sharp, and you can see clearly that they are all going towards the east. So it's going to be 150 Newton towards east, all right? Towards east. Okay, so at this point in time, I have actually gotten the answer. All right, so from here we can now move over to the next example. All right, now behold this simple question. All right, now let's trash this question. Okay, the question says that a sailor sails on a Sunday morning towards the west. If the force of the wind acting on the ship is 45 Newton west, find the resultant force moving the ship. And then in brackets, force of propulsion of ship is 150 Newton. Okay, what does this mean? It means that the ship is going towards the west. Yes, the west. Of course, the west is this direction. Okay, you saw the cardinal point just now. Now, the ship is going towards the west with a force of, according to the bracket, is 150 Newton. Okay, and then there is also wind pushing the ship. Okay, and according to the question, the ship and the wind is also, pushing the ship with a force of 45 Newton towards the west. Okay, so the one of the wind is 45 Newton, and it is also towards the west. Now you are asked to find the resultant of the force, or sorry, the resultant force moving the ship. So what are you going to do? Since both forces are going in the same direction, you just sum them up, okay? Because vector acting in the same direction, you get their resultant by, just directly adding them up, 1 plus 1 plus 1, normal addition. Just add them up, okay? So resultant will be equals to 150 Newton plus 45 Newton. Okay, so this is a total of 195 Newton. Okay, but you have only given us the magnitude, you have not given us the direction. What will now be the direction? The direction is towards the west because both of them are going towards west. Okay, the direction is always the direction of the vector. Since two of them are going west, then the resultant should also go west. All right, now that is all for vectors acting in the same direction. Let's go over to vectors in opposite direction. Now we are looking at vectors acting in opposite direction. Okay, in opposite direction. Now take note that vectors acting in opposite direction, the angles between them is 180 degrees, the same as the angle on the straight line. Okay, is 180 degrees. Remember that for same direction it was 0 degrees. Now for opposite direction it is 180 degrees. Please, these angles, they are very important, to make sure you don't forget them. Okay, now having known the angle, what else do you need to know? Vectors acting in opposite direction, they are also called anti-parallel vectors. Okay, anti-parallel. They are also called anti-parallel vectors. Meanwhile, the same direction, you just remove the anti, it remains parallel. Okay, that's parallel vectors. Okay, so these ones are very important. You should take note of them. Now, when we say vectors are acting in opposite direction, what does that even mean? Now, take for instance, there's a box here. Okay, let's say there's a box here. The box is actually on the ground. All right, on the ground. So the box is on the ground. Okay, and then I am applying a force on this box to move it in this direction. Let's call that F1. Okay, and then there's another force pushing the box in this direction. Let's call it F2. All right, so you can see that like both of them are going in two different directions. Now, how do you now solve for the resultant in this kind of case where the vectors are in opposite direction? How do you get the resultant? Well, it is very, very cheap. It's very, very easy to get. So how do you do it? Well, this is how you do it. The resultant vector arrow is equal to F1 minus F2. Okay, now you make sure that your F1 is always the larger vector and the F2 is the smaller one. Okay, so let's take for instance that this place is, let's say 100 Newton for instance, and this one is, let's say 70 Newton. So at this point in time, your F1 will be 100. Okay, so equals to 100 minus 70. So this will give you 30. Okay, 30 Newton as the final answer. That will become the resultant. All right. Now, if this one, let's say this one is 100 Newton and this one is, let's say 200 Newton. So at this point in time, this guy becomes the F1 and this one becomes F2. So the largest one among them will always be your F1, so that you will get a positive answer. So you don't get a negative answer. Because if it takes as F1, it takes as F2, it will now be 100 minus 200, so now give minus 100, which we are trying to avoid because you cannot get a negative answer for this kind of situation. Okay? Now, you have seen how to get the resultant. If they are acting in opposite direction, you subtract. But if it is the same direction, like one of the previous case 2, we are done with case 1, okay? This is case 2. Now, if it was the one we did before, which is vector in the same direction, then that would have been, addition. But now it's opposite direction, so it's subtraction. Okay, now let's look at some examples, okay? Now, this illustration, is what we're going to be working with. Now, look at this illustration. You can see that 18 Newton and 20 Newton, they are pushing the object towards east. 15 Newton is pushing it towards the west. Okay, so at this point in time, how do we get the resultant? Okay, so the resultant is equal to those putting it towards the right. You first of all add them up since they are going in the same direction. 80 plus 20 will give you 100. So that's 100. 100 become my F1. This is F1 minus F2. All right, so F1 is now 100. Or you can still choose to just put it as 80 plus 20. It's still the same thing, okay? Minus F2, which is 50. Okay, so together it will give you 100 minus 50. This is equal to 50 Newton. Okay? Now, what about the direction? Please take note that the direction you have to work with whenever it is opposite direction is the direction of the larger vector in the question. Okay? So there is 50 Newton towards west, a total of 100 Newton towards east. So 100 is bigger than 50. So the direction of this 100 will be our final direction, which is towards the east. Okay? 50 Newton towards the east. So these are our final answer. Okay, so with that, we have come to the end of this particular part. So in the next video, we'll be looking at addition of vectors that are perpendicular to each other. Okay, we'll be working with perpendicular vectors. That's vectors at an angle of 90 degrees. Okay, so until then, see you in our next class, and do have a nice day. If you have a question, please drop it down in the comment section. And if you are watching this on YouTube, please subscribe to our YouTube channel, and if it's on TikTok, follow our page. Thank you. God bless you. See you in the next video. Bye.